For our last 15 minutes today, I'm going to introduce section 7.2, another method of integration called integration by parts. Section 7.2 is integration by parts. These methods are indeed kind of mysterious, okay? So far with substitution, I just essentially told you what to do and you've done it. Same kind of thing is going to go on here with integration by parts. There are reasons why these things work. They're not arbitrary. We've noticed that with substitution, whenever we check our answer with differentiation, we have to use the chain rule. With integration by parts, whenever you check your answer, turns out you always have to use the product rule. Substitution is kind of the reverse of the chain rule. Integration by parts, it turns out, is the reverse of the product. So it's not really clear why. We'll get into why on Wednesday. It's also not always clear what you should use. Should I use substitution or should I use integration by parts? One bit of guidance that I gave you with substitution is to choose W to be something where dW is almost in the integrand function, at least up to a scalar multiple of the function. With integration by parts, one bit of guidance that works oftentimes, though not all the time, is to choose new variables called U and V prime to be something where, well, V prime is easy to integrate so that you can find V, and U prime is easy to differentiate and hopefully simpler. What in the world? What am I talking about here? I want to integrate this product of x with sine of x, x times sine x. I want to represent that product as the product of two functions, the first of which I'm going to call u and the second of which I'm going to call v prime. Why u and v prime? Because, well, I'm going to find the derivative of u, I'm going to find u prime, and I'm going to integrate v prime to get something I'm calling v. Because the integration by parts formula turns out to say that this will equal u times v minus the integral of v times u prime. Everything with respect to x. Everything depends on x. U and v prime are functions of x. Say it again. Listen carefully. I've got this integral that's a product of two functions. Integration by parts separates those functions into two pieces that are being multiplied, u and v prime. You are going to want to find, because of this formula, v. You are going to want to integrate v prime, in other words, because v appears in the formula. So v prime better be something easy to integrate. And you also see a u prime appearing in this formula. So u better be easy to differentiate. And hopefully, since the right-hand side of this formula involves another integral, hopefully u prime is simpler than u so that this integral is easier to do. That's a lot to take in. Let's see how it works out. So let's focus on the u first. Should I let u equal x or should I let it be sine x? If you let it be x, that has the positive effect of having a derivative that's simpler. So that's good. So if you let u be x, then v prime has to be the other factor, in this case, sine x. And that is something that is relatively easy to integrate. Integral of sine of x is negative cos x plus c, though you can take the c to be 0. It's only at the very end of the problem that we're going to put on a plus c. Use the formula. Again, it's mysterious. I haven't told you why it works. It's definitely mysterious at the moment. It says first do u times v. Multiply these two things. Look where I'm pointing. multiply those two things, x times negative cos x, to get negative x cos x. Minus the integral of v times u prime, the product of these two things. Minus the integral of negative cos x times u prime, which is 1. So that's uv minus the integral of v times u prime. And yeah, that's an easier integral to do. In fact, you can bring the negative sign out in front and put a plus sign. That's a relatively easy integral to do. Integral of cosine is sine. Now put your plus c on at the very end. Done. We should definitely check this. Check it. Differentiate it with respect to x. Notice that the first term is a product. We need the product rule, just like I said a few minutes ago. The derivative of negative x is negative 1. That's the derivative of the first function times the second function. Careful about signs, plus the first function times the derivative of the second, and the derivative of cosine is negative sine x. Very easy to make a mistake. Don't forget to differentiate sine x, which is cos x. And yeah, the derivative of c is 0. When we simplify this, lo and behold, like magic, the cosines cancel, and you're left with x sine x, which is what we were hoping. That's the original integrand. It worked. Yes, mysterious? Again, we'll talk about why it works on Wednesday. This guidance, though, in particular the guidance of letting u be something whose derivative is simpler, is not always the best guidance. The more important guidance is v prime is something easy to integrate. And that's going to happen in our next example. And this will be our last example for the day. Integral of another function that's kind of similar to the previous example. The previous example was to integrate x times sine x. This example is to integrate x times natural log x. So it looks similar, so we think we should probably use integration by parts again. Define new variables u and v prime to be the factors of this product. Maybe u is x and v prime is natural log of x, or maybe u is natural log of x and v prime is x. Now, if u were x, then u prime would be 1 and would be simpler. However, that's bad here because that would imply v prime is natural log of x, and it's not so easy to integrate natural log of x. It's not something you can do in your head, most people. The derivative of natural log is easy. That's 1 over x. But we don't want to differentiate natural log of x in that case. We'd want to integrate it. So counterintuitively, we actually want u to be natural log of x and v prime to be x, which is the opposite of what happened in the previous example. Because more importantly, v needs to be something easy to find. We need to be able to integrate v prime. 1/2 x squared. U prime, yes, is easy to differentiate still, and is simpler because it doesn't involve a log, I guess you could say. But more importantly, v prime is something easy to integrate. Once again, the formula says, and I'd recommend writing this formula down every time you use it. On regular exams, including the mini exam on Friday, you can use a note card, though on the gateway you cannot. However, if you practice this formula by writing it down every time, it will definitely help you in future classes where your professor in your physics class is using it and not, they're just saying, I'm going to use integration by parts here, and they're not going to show you the steps. And you're like, I want to know those steps. So you want to check them after class. If it's in your brain, well, it does save time, at least. There's what it looks like. So for this example, u times v is the product of these two things. So it's 1/2 x squared times natural log of x minus the integral of v times u prime, 1/2 x squared times 1 over x. And at least that integral doesn't have any natural log anymore. Yes, it's easy to do if we can cancel this x with one of those. And we ultimately can bring the 1/2 out in front as well. We're ultimately integrating x. And here's the final answer. We'll check it in a second here. Before we do, one comment here is that you do not need absolute value signs around that x, contrary to what we did when we integrated 1 over x. Why? Because in writing this integral in the first place, I'm implicitly assuming x is positive. It's because I've got a natural log of x in there without the absolute value signs. So I'm implicitly assuming x is positive when I write this, so you don't have to write absolute value signs there. It doesn't hurt, it's not wrong. You just don't need to for this kind of problem. Check it by differentiation. Once again, for the first term, we have a product. We need the product rule. The derivative of 1/2 x squared is just x. So there's the derivative of the first times the second, plus the first function, 1/2 x squared, times the derivative of the second, which is 1 over x, minus the derivative of 1/4 x squared is minus 1/2 x. C differentiates to 0. This simplifies to 1/2 x, which means it cancels with this. And the final answer is what we want it to be, x times natural log of x, which matches that. So it does check. When you do definite integrals with integration by parts, you do not change the limits of integration. Because all along you really are still sticking with x's, even though you see u's and v's here. In the end, these u's and v's are functions of x. So you're still using functions of x. So no need to change the limits of integration. You only change them for substitution. Okay, so don't forget, for the definite integrals substitution problems due Wednesday, do it with the new method. Have a good day.